Hi, my dear friends. This is Ranjith. I hope we all went through the last video where we were talking about data science linear algebra part 1, and we were going through the real examples how we can bring an equations where it can help uh, team to understand the predictor value by putting independent values, right? So today I am predominantly focusing on how to calculate two variables, sorry, how to calculate two equations, which is linear equations and which is two-dimensional. Uh, we have a models ready, two different models ready, and combining two models together and find out its x and y value through uh, raw picture and column picture. We will be going through the school days where we were trying to draw the graphs and finding out the values on x and y, connecting two lines together and find out the solutions of x and y. Then matrices, vector, how to multiply these and try to find out the coefficient. So there are two ways we can find out the values of x and y of two equations. One is through the raw picture, nothing but x and y coordinate, and finding out x and y values, and draw two lines. If two lines are connecting together at certain point, and we find out the values of x and y, and find out and say that, and this is the solution for these two models. And there is another way is called column, where we take all coefficient and all dependent and independent and put into matrix and vectors and do the multiplications and present in the graph and find out the coefficient of values. So all these we are trying to do to understand the fundamental of how to get a predicted values by putting independent values. So all are in our x and y plane, but based on the model we have to find out, choose the values there and understand. So here we are trying to find out x and y values, but in the real scenarios we will not be knowing the coefficient, right? If the real problem comes, we will not be knowing the coefficients, but we know what are the independent values. In our hand we have the independent values, and based on that and based on the situations of the problem, we find out the coefficient and create an equation, then find out the y value. That is what data science looks. But to understand that level, we need to do the reverse way. Means we already have a coefficient with us, we already build a model, trying to find out x and y value out of it. That's what I'm trying to do this video today. Let me try to give two equations and do a pictorial and as well as pictorial representation in terms of row as well as column. There are two equations here. Let me try to write those two equations. First equation is x minus 2y equal to 0. And second equation is minus 2x plus y equal to 3. So here, if you look at x and y are variables, one is independent and another is dependent. And there are different coefficients. Here is 1 coefficient, this is minus 2, 0, minus 2, 1, and 3. These are the coefficients, right? These coefficients, here we already have in this model, but in the real data science world, we try to find out this coefficient based on the data which we are having it, right? So I'm talking in the reverse way now. Once we understand the reverse way, then we in the next upcoming videos I'll try to explain more how to bring the coefficient, how to get the coefficient values out of uh, the data which is given in the x and y, sorry, xy plane, right? So now let us try to find out the value of x and y through a raw picture. The raw picture is nothing but try to draw x and y coordinate and find put some values for x and y, and let's see where these two models are joining together. Let me try to draw y axis. This is y, and this is x. Pardon with me, my handwriting is a little bad, but let's go together. So this is 1, 2, 3, then 4, 5. Same way we'll write here also. Right. And this is again y, but it goes minus values. 4 and minus 5. Same here, minus 1, minus 2, minus 3, minus 4, and minus 5, right? So first equation is x minus 2y is equal to 0. We know since it is a 0, the first point is an origin, right? All the points or the line connecting the points of this equation always go through 0. So the first point is 0 here. And let's try to find out another point. Let's have x is equal to 1. If x is equal to 1, if you put x is equal to 1, then y became 0.5, right? So if x is equal to 1, y is around here. Because this is 1, so y is around here. And we have another point here. Let's try to draw a line. This is one straight line going through origin. Now, for the equation minus 2x plus y is equal to 3, let's put x is equal to 1. If x is equal to 1, we have y is equal to 5, correct? If x is equal to 1 means y is equal to 3 plus 2 is equal to 5. We have one point here. Let's bring another point. Let's see, let's happen when x is equal to minus 1. When x is equal to minus 1, what will happen? This will be 2. Then y is equal to 3 minus 2 is equal to 1. So if x is equal to minus 1, y is 1. So we have 2 points here. Let's try to draw a line between these 2 points here. When you draw a line, so line, the point will be here. So it's what's the coordinate of this point? It is minus 2 and minus 1. Means these two model is joining in two-dimensional plane at a point of x is equal to minus 2 and y is equal to minus 1. So x is equal, we found value from these two models through raw picture. X is equal to minus 2 and y is equal to minus 1. So these are the two values we found it. So let me explain once again in the real world scenario. We will have we have a coefficients already there in these two equations. Based on the coefficient, we will try to put number of independent values. Based on the number of independent values, we get a dependent value and try to connect the line between dependent and independent values of these two equations, or means two models. Let's see where it is going to join. So that joining point is a common solution or common value which meets these two equations. In that point, we can find out x and y value. That means if you give x value of that, you definitely get the y value. So here, as I said earlier, we are doing the reverse way of finding prediction. We already have a coefficient here. We already have a coefficient here, and we are trying to find out x and y value. But in the other scenarios, we will have x values. We will have x values, but we will find out the coefficient through the loss function and gradient descent, which I will talk in the upcoming videos, and find out the predicted value y. So now this is a raw presentation. So now let's go to the column presentation or column way of pictorial representation of this equation, where we will divide this, not divide, we will convert this equation into matrix and vector format. Let me write the equation again here. X minus 2y equal to 0. then minus 2x plus y equal to 3. So how we can convert this into a column presentation? So there's the one way we do it. So let's put into a vector and matrix format. Right. So we know x minus 2y is equal to 0. That means we have the first point here, minus 2. Then we have x here. Same way we'll put minus 2 here, then 1 coefficient. Here is a y. Then equal to the right side is another coefficient, 0 and 3. So this is called matrix because in matrix, anything two-dimensional or more than two-dimensional data points, we have it. We can put it in a square bracket and put the values in a square bracket. That's called a matrix. And I know we learned in our school days what is matrix, correct? And the other one is a vector. Vector is one dimensional which has a direction, and x and y we put in one dimension and which is called vector. So this is 2 by 2 matrix. When I say 2 by 2 means 2 row and 2 column, 2 by 2 matrix. And this is 2 by 1 vector. Again, we get another one, 2, 1, 1 vector. So there is a formula connecting between matrix and vectors. So to do a multiplication between two vector or two matrix, if left side of matrix column should be the column number should be equal to the right side matrix row numbers. So in this case, here we are multiplying matrix versus vector. So if you look at the column of this matrix, which is 2, and the row of this vector, which is 2, it should be equal. If it is not equal, we need to transpose it, which is called transpose of vector or transpose of matrix. But to communicate or to multiply between either matrix or between matrix or between vector or between matrix and vector, we should have this should be equal. The number of rows, number of columns of the left side should be equal to number of rows of the right side. So now what we'll do is we'll try to multiply these two. When we do that, so as part of easy multiplication, what we can do is still we can convert the matrix into two vectors. Let me do that. So 1 minus 2. This is one vector. And we are trying to multiply with x. So into x plus, again, another vector, minus 2, 1 into y is equal to the right side part. So we don't know the right side part, right? So let's keep as a blank now. We'll try to find out the right side. And we already know what is x and y from our raw representation. That is x is equal to minus 2 and y is equal to 1, minus 1, right? Correct. So this is our value here. So what we are trying to do here is let's put those values x and y here. Again, let us write the same vector into minus 2 plus another vector minus 2, 1 into minus 1. Then let's have the blank. So we are trying to find out this value. So we got this situations now. That means the left side is a vector of 1 minus 2, multiply by -2 again, then adding into another vector -2 and 1, multiply by -1, and trying to find out a value here. Let's try to draw this vector. So what we did till now is we put the equations into matrix format, and that matrix we divide into two vectors and try to find out its coordinate of vectors through x and y, which is called column representations, right? So let me try to draw x and y here. X and y. So here, if you look at 1 and -2, that means x is equal to 1 here, y is equal to -2. So it will come, rather than putting x is equal to 1 and -2, we already multiply with -2. So let's try to bring minus inside of vector. So how it will be? So let me clear this coordinate here. So let's simplify this again. So it will be another vector with -2. Then it will be sorry, it will I think I did it. So if you put minus inside, what will happen? -1, then 2, right? Into 2. So when we put this value here, it will be -1 and 2, then into 2 plus. Again, we are putting for this vector. So it will be again 2 -1 into 1. Then we have a right side coefficient, which is blank right now. And now it's easy to present into a pictorial representation. So let's try to draw x and y coordinate of it. This is y and x. So this point, this vector, let's represent this vector, how it will be. It's, let x is -1 somewhere here, and y is 2 somewhere here. Let me try to draw a little more. 2 somewhere here. So vector will be like this, right? This is a vector. So as I said, vector is nothing but is a single dimensional value. It has a direction. So the direction of this vector is towards this. Means x is equal to -1, y is equal to 2, and this shows as a vector. But this guy is multiplied by 2, right? So if you multiply 2, again we are multiplying with another vector. So another -1 comes here, which is -2 here. Let's put -2 here. So it will be this one and +2. So it will be another vector like this. So here is a point 4. So this point will be -2 and 4, right? -2 and 4. This is the point. So this is the vector. This vector into 2, this is the vector, right? Now let's have another vector here, which is 2x 2 -1. So x will move x2, and y is equal to -1. So it will be coming around like this point. This is around 3. So this will be another vector. So this vector we are moving 2, positive 2, and y is equal to -1. So this is the direction of this vector. So altogether, the combination of this left side and right side vector is, this is the diagram. And we got a point here. So what this point? This point is belongs to 0, 3, right? Which is what we already have. Which is what we already have the value here, 0, 3. And we are finding 0, 3 through this vector direction. So we got 0, 3. So multiplying these two vector, and we found x is equal to -1, y is equal to x is equal to -2, y is equal to -1, and we got the coefficient 0, 3. In the very first one, what we did is raw picture. in that raw picture, we already have a coefficient in the right side, right? And through the connection between two lines, we found x is equal to -2 and y is equal to -1. But when it comes to the column picture, we found a x value. We converted in these equations into two matrix and vector. And in matrix and vector, try to multiply using the value which we found from the column picture, x and y, and find out the coefficient. Yeah. So through this exercise, what we are trying to achieve here is, if we have two models with us, which is lying in an x and y plane, we can have, if we have multiple observations, and it's observation is independent variables, x is an observation, and if we have the coefficients we found based around the gradient, descent gradient, and loss functions, we can create a model, and from that model we can find out a predicted value. So that is what data science does. But in this, when we talk about the linear algebra, we had an equations, we already have the equations, and we are putting value of x, and we are finding out the value of y. X and value we are finding through the raw picture, and once we have x and value y, we are finding the coefficient, right side coefficient, through the column picture. So in column picture, what we are trying to do is we are converting the equations into matrix and vector, and again matrix we are subdividing into two vectors for easy way of calculations. We already found x and y value, then multiplying vectors with x and y values and draw through a column diagrams through the different directions of vector and find out the endpoint of vectors. We divide into three vectors. Basically, the left side we have one vector into two, then right side the other part of equation another vector into one. So total we have three vectors. We draw a diagram of three vectors together. At the end of this diagram, so end of the directions, we reach one point, which is the right side value. Here it is 0, 3. I hope this video gives you a basic understanding of how the equation looks, two-dimensional equation looks, how we can get x and y value through the raw picture, how we can get the coefficient, right side coefficient, through the column picture, and in the column picture, how we modified into matrices and vector, and how we multiply two matrices to reach the coefficient. In the next video, we'll continue the linear algebra, and slowly we'll reach into a certain level where we will try to create a model and train the model and try to get the predicted values going forward. So I hope this video gives a basic understanding of linear algebra and how the data science need the basic understanding of linear algebra. Thank you all. Thank you all for your time. Thank you very much.